Hello dear students, this is the same numerical I tried to solve in the previous video lecture of airport engineering lecture number 3, but due to some technical problem this problem did not appear correctly, so I have once again tried to solve this. The same problem, the length of runway under standard conditions is 2100, this is 2100 meters. Okay, now where we have to provide the airport runways at the elevation of 410 meters, which is above mean sea level. Now the airport reference temperature is 32 degrees centigrade, even though we have seen that the formula for the airport reference temperature is TA plus 1/3 of difference of mean temperature and the TA. Most of the times this airport reference temperature will be given, you need not do the calculations for this, and the data for the gradients is given like this. So in the table the changes are between 0 to 300, there is a gradient of +1, so there is a rise. Then again for the next 300 to 900 this is a -0.5, so you must have seen that the interval is not constant. Here is the difference of 300, here is difference of the 600. So likewise this table is given to you and you have to calculate the actual runway length. Okay, coming to the solution, first we have to go for the correction for the elevation. Now the correction for the elevation, there is always the 7% of the basic runway. So what is 2100? It's a basic runway length, and this is for 300 meters, so 7% against the 300, but we know that this is the value of 410 meters. So simple, by the cross multiplication, if you try to calculate, this value will come out as a 210 meter. That means above the basic runway length there is a rate of 7%, so the value is coming out of 201 meters at the elevation of the 410 meters. So therefore the corrected length will be 2100 plus 201, so the total is 23. Okay, so this is the value coming out after the corrections for the elevation. Now going to the correction for the temperature. So before actually applying the formula for the correction for the temperature, we need to first of all calculate what is the standard temperature, because standard temperature is the 15 degrees centigrade, but this 15 degrees centigrade is at the mean sea level. So you can equivalent to that standard reference temperature at mean sea level to any elevation. So in our problem is 410 meters. So if you calculate for our given elevation, what will be the equivalent standard temperature? So you have to calculate 15 minus, and this is the formula for this. Question is that why minus? Because we know that as we go on higher altitude the temperature will fall down. So therefore here the value is, whatever the value we are getting, it is less than the 15 degrees centigrade. So therefore if our problem case 410 meters, the value will be coming out as a 12.34 degrees centigrade. So note it down please. The 12.34 degrees centigrade is the standard temperature, which is equivalent to standard temperature at mean sea level. This is the temperature, not the what is your reference temperature. So reference temperature we have to calculate. Okay, so going to the next step, correction for the temperature. Actually here now we start calculating the correction for the temperature. So in this case we have to first of all calculate the rise of temperature. What is the meaning of rise of temperature? So the temperature above standard temperature, the difference of this we call it as a rise of temperature. If it goes down, then we call it as a fall in temperature. But most of the case, as we go for the designing of the airport runway, always above the mean sea level, and that is at some elevation, therefore we always get the rise of temperature. Now this rise of temperature we have to calculate, as in our problem the 32 degree centigrade is the at 410 meter which is observed, and from this if you subtract the standard temperature, that is 12.34 that we have just calculated, so the rise of temperature is equal to 19.66 degrees centigrade. So what is the correction then for the temperature? Correction will be, so you will see the basic formula for this. It's a 1 degree centigrade rise against the 1 percentage increase in the elevation. Okay, so 1 degree centigrade against the 1 percentage increase in the elevation. This is we call it the rate of change of the elevation. So therefore we know that or the runway length, this is the after calculations of the or applying the correction for the basic runway for the elevation. This is not the your basic runway length after the calculation the elevation, and this is a percentage there. So if we say if it is a 1% after every 1 degree centigrade, so we want to know percentage 2301 upon 100. Okay, the entire is the 2301 upon 100 the percentage against the 19.6. So we know that this we have to apply 19.66%. So this will come out to be 454 meters. Okay, so finally for getting the correction corrected length for the temperature, here we have to apply the which already calculate the correction for the elevation plus the corrected temperature, and the value is coming out to be this. Now here we have to go for the check because ICAO, that is the International Civil Aviation Organization, suggests that this total correction, that is elevation and temperature together, should not exceed the 35%. So we have to calculate how to calculate the percentage increase above the basic runway length is that together applying the corrections for the elevation temperature, the value is 2755, the basic runway length is 2100, and so taking the difference of this against the basic runway length, we call it the above that we want to calculate, so therefore which is coming out to 31.2%, which is the on very safer side. Okay, correction for the gradient, we want to calculate the, because the gradient is not constant, it is not a one surface, but the ideal case where we assume that this is the only plane surface, and this does not happen, and even it is not practical to provide this plane surface on the basic runway length. So we go for the correction for the gradient. Now what is this gradient? So you know that even though there is a somewhat change from chain edge to chain edge, this changes, but we have to provide one uniform change the surface, and that uniform surface we call it the effective gradient. So that effective gradient, if you want to say the difference between the what is the maximum the difference between the maximum and the minimum elevation on the basic runway itself. So to calculate this, the difference, we have to calculate what is the maximum and the minimum elevation. So take the help of the table given in the problem. So this is the chain edge and the elevation. Now in the problem the values given, let us say for 0, 300, 900 meters, it is given in percentage. So question is that how much is rise in the elevation for all the different chain edges. So we have to convert this equivalent to meters of distance. So to actually start with this, for the 0 chain edge, you can consider any RL values. So 100 meters if I assumed, so you can take any value, either 100 or 10 or 50, any value. Now next to that, if it is said that after 300 meters the rise will be, because it's a plus 1%, so that means over the 300 meters 1% rise is equal to 3 meter. So therefore above this the rise is if you say the add this, rise is equal to 100 plus 3 is equal to 103 meters. Now after that the difference between these two is 600 meters, but there is a fall of minus, we can say 0.5, so therefore this value will be going down. So again 600, so we can say 600 means 0.5% is coming out to be again 3. So therefore there is a fall off of 103 minus 3 is equal to 100 meters. So like if you say calculate for all the different changes, the corresponding values for this will be calculated like this. After having calculated, we have to identify which is the maximum elevation amongst all the values. So if you say that for 1800 meters, the value is found to be 106, and which is the lowest one. So if we say the lowest one above this 100 for the zero change, and this is also 100 change. So what change is not important for us. Just thing is that which one is the lowest one. Okay. So therefore, if you say maximum difference of elevation is equal to 106 minus 100, which is coming out to be 6 meters. Now to calculate the effective gradient, there is a the percentage is that the percentage which is given as this one. We have to first of all calculate the percentage. Why this is percentage? Because for the different changes, the values are given in the gradient form basically. So basic the presentation is in the percentage, not in, because meters rise we have for our convenience, for timing we have considered, but the effective we have to calculate in the percentage. So therefore 6 meters is the gradient, effective gradient, sorry. So therefore in percentage we have to calculate as a 0.218%. Now after having calculated these corrections for the go for the correction for the gradient. So it is said that for the percentage, there is a 20% increase. There should be percentage of 20% increase to the combined corrections or corrected length. And so therefore question is that for 0.21%, how much will be there? So if again you go for the cross multiplication, so this together multiplied by 0.21, because for 1% it is like this. Okay, so 0.21% is how much, right? So this is coming out to be 120.5 meters. So therefore final the correct laid length is equal to 2755 plus what is this value here, 120.5, and this one. So 2875.5 meters is the corrected length for about the basic runway length, and is to be considered for the design of the runway length. So I hope you understood this. After this I'm going to upload the next video lecture for the different the runway markings and the what are the different visual aids. Thank you very much.